Okay, so we're moving over to 7.1. We're doing lesson 7.1 today, obviously. So as you can see, there's like practice problems here, but these are also our notes. So I'm just going to add theorems here and there as it's appropriate. The theorem that we're going to be working with on this page, and I'll use abbreviations as well as much as I can, is Polygon interior angle theorem. You've kind of already seen this in a way. The interior angles of a triangle, for example, the interior angles of a triangle add to 180, and it doesn't matter like what that triangle is, those angles are going to add to 180. Well, the same holds true for like quadrilaterals and pentagons, but the number is not 180. I think it's 360 degrees for quadrilaterals and 540 degrees for pentagon, and every shape has its number of what the angles will add up to. It's not realistic to obviously memorize all of those numbers, so they give us an equation. So the sum of the measures of the interior angles is n minus 2 times 180. Okay, and n refers to the number of sides. But when you have a shape, for example, like a pentagon, you can count the sides 1, 2, 3, 4, 5. It's actually the same number of corners, 1, 2, 3, 4, 5. So number of sides or corners, however you want to think about it. And since we're dealing with the angle measures, it might be easier to just think of it as like 5 corners. Okay, so now we're going to use this in the problems. So it says find the sum of the measures of the interior angles of the indicated polygon. So a nonagon would be 9 sides. That's why that lesson was in Alex this week. 9 sides, nonagon. So what you do is we're going to use this equation, 9 minus 2 times 180. We're just going to plug in 9 into the equation. So 9 minus 2 times 180. 7 times 180 comes out to 1,260. So that is the sum of the interior angles of a nonagon. So all the angles of a nonagon would add to 1,260. Then number 2, 14 gon. So that means 14 sides or 14 corners. 14 minus 2 times 180. 12 times 180. Of course, you'd plug that into a calculator. I've just already done that process, and it comes out to 2,160. So a 14-sided shape, the vertices or the corners would add up to 2,160. We're going to cross out 3 and 4, but I think we get the point. We're going to look at it a different way in the next set of problems. Okay, so for the next set of problems, they give you the sum of the interior angles. So this is like the answer. It equals 720. Also, we're not going to do this problem, so you can use this space over here if you need to. So this is the sum, and then we put that equal to the n minus 2 times 180. Okay, so I don't know why they put the 180 on the back end of this, but we're going to do the same thing that we did in the bell work, just distribute this 180 to both these terms. 180n minus 360 equals 720. And then we're solving for n, the number of sides. Divided by 180, we get n equals 6, so that means we have a hexagon. Okay, then we'll try one more of those. We're going to do number 7. We're not going to do number 8, so if you want to use that space, you can. N minus 2 times 180 equals the total 25 to 0. And then we're solving for n, so we'll just distribute this. 180n minus 360 equals 2520. Divide by 180, and we get 16, so a 16-sided shape. Once you have that number, sometimes they'll ask you like what each individual angle is. So each angle, you would just do 2520 divided by 16, and each angle would be 157.5 degrees. So sometimes they'll take it one step further. Of course, the each angle would only apply if you had a regular polygon where like all the sides were the same, but often it is. Okay, it gets simple again. Okay, for 9 and 10, these are quadrilaterals. Quadrilaterals, the angles add up to 360. You could sit there and solve that every time, but that's one that you might just want to memorize. All quad angles equal 360 degrees. So for this one, we have 3 angles right there. We can just do 360 degrees minus these 3 angles equals x. So x would equal 64. You just plug it in a calculator and it'll come out to 64. Then for number 10, same idea, 360 minus these 3 angles equals 66 degrees. Okay, 11 and 12, we'll cross that out. We're going to do number 13. So 13 is the same idea, but they didn't give us a quadrilateral, so the angle measures don't add to 360. We have to figure out what they do add to. So I'm just going to count the sides, 1, 2, 3, 4, 5, 6 sides. So then we can use the equation n minus 2 times 180 to figure out the total angle measure. So 6 minus 2 times 180 is 720 degrees. And then to find the missing angle measure, 720 degrees minus this. And it comes out to x equals 70. There's one that goes along with this that comes up on the homework that I want to go over. So on the homework, this example, and I'm going to, again, abbreviate it as much as I can. Each interior angle is 160 degrees, and they want to know how many sides. How many sides? Okay, so the way you would do this is, okay, so each angle is 160, so 160 times the number of sides would give you the total angle measure, and then you can put that equal to your n minus 2 times 180, and then solve for n. So you distribute this, 180n minus 360 equals 160n. And this exact problem is on homework. If you get it, you'll already have it worked out. Subtract 180n. Then n equals 18. We are going to do a couple on the back just so far. You know, it's kind of a long lesson for like the start of a chapter. Normally it's quicker. Okay, next. We're actually going to skip this side because our brains are getting tired already. So we're going to skip this side and then move over to, should I zoom out or is it going to be blurry? Are you able to follow it? So we're skipping this side and we're just moving over to 21 right here. Okay, so on this page, if you look at it, all the angles are on the exterior of the shape. So on this page, we're just talking about exterior angles. So there is a theorem for this, exterior angle theorem. And this theorem is actually easier than the one we just did. Exterior angle theorem says that all exterior angles add to 360 degrees. So it doesn't matter how many sides the shape has, they all add to 360 degrees. So for 21, to find this missing angle, these exterior angles add to 360, so 360 minus these three angles equals 111 degrees, and that's the answer. Okay, we're going to skip that. We're going to do 23. Of course, they give you a little bit of a curveball. All the angles add to 360, but they gave you a 2x and a 3x for two of the angles. So 2x plus 3x plus 71 plus 85 plus 44 equals 360, and that is how you would solve for x. This adds to 200. I know your brains are dying at this point. 5x equals 160, 32. Okay, one more, and then we're off to the homework. Okay, 25. It says find the measure of each interior angle and each exterior angle of the indicated regular polygon. This little word regular is actually really important. It means that all these sides of the shape are the same and all the angles are the same measure. So regular seems inconspicuous, but it's actually really important. In these regular shapes, all the angles would be the same measure. So for pentagon, which is 5 sides, it wants to know each interior angle and each exterior angle. Interior angles, you use the equation n minus 2 times 180. So you would take the 5, plug it in, and you get 540. But that is the sum of the interior angles. That's all of them together. So to find each one, you would need to take it one step further and divide by 5 to get each angle. So that's the interior angles. And then exterior angles, they add to 360. So to find each exterior angle, just 360 divided by 5, and it comes out to 72 degrees. That's it. So on here, you have a sample of all the questions you could get on the homework. Also on ALEKS, when you looked at it yesterday, you probably didn't know how to do this, but now you have a sample of all the ALEKS questions as well. So go ahead and get a laptop, get started on the homework. I'll publish it for you as well. If you have questions, let me know.